Okay, welcome America, welcome Taylor Swift. Today we are going to do a quick review of ways to prove triangles congruent. We're going to start with this slide. So let's start with this one right here. Take a look at this triangle. We have three sets of corresponding sides that are congruent. So which method is this for proving triangles congruent? This information guarantees these two triangles are congruent. These two triangles are congruent by, what's this called? Side, side, side. Boom. Excellent. Next one. I just pick one. Here we go. Notice we're given two sets of angles that correspond to each other. This angle corresponds to that angle, this angle corresponds to that angle, and we also have one pair of sides that correspond to each other and are congruent. The side is in between the two angles. So, since in the diagram the side is in between the two angles, in the name the side has to also be in between the two angles. So what way to prove triangles congruent? What's this called? Angle, side, angle. Okay, this one. We again have two sets of corresponding congruent angles, and we have a side. However, the side is not in between the two angles. It's on the outside of the two angles. So, in the name, the side also has to be on the outside of the two angles. What's this called? Yep. And if you write it like side, angle, angle, it's the same thing. It doesn't really matter which direction you go. I don't know why those won't click. There we go. All right, this one's only got one angle, and we've got two sides, two pairs of sides. And the angle is in between the two sides. So what's this called? Side, angle, side. This is SAS. Here we go. And here, this one, two angles and a side. The side's on the outside. It's called the non-included side. Sometimes they call it the non-included side. So what's this called? Yeah, I heard someone say side, angle, angle. That's fine. Angle, angle, side is how it's listed up here, and that's usually how they list it, but it doesn't matter to me. It's the same thing. And last one, what's this one? Angle, side, angle. You guys are getting better. How do you guys feel? Were you guys okay with, did you guys learn this last class?
Yes.
Kind of, sort of. Okay, good. So this is a good review then. All right, what else do I want to review from last class? Hidden information. I'm not going to go through this whole slide, but what I want you to notice is if I wanted to redraw these two triangles separated, okay, the information that's on this diagram tells us that those sides are congruent. But it also, you see how they share this side? We can assume that length is the same in both triangles. So if I separated the two triangles and drew them, I'd have to put a mark here. So anytime you get a shared side, they have that in common. That's an extra side that you know. The other type of hidden information is when you have vertical angles. Anytime you have lines that intersect, they create vertical angles. Vertical angles are congruent. They don't draw them on the diagram, but they're there. And if you miss them, you don't have enough information to prove triangles congruent. So in this case, now that we know that those angles are congruent because we have vertical angles, we can tell that these two triangles are congruent by angle, angle, side. If we didn't see the vertical angles, then we would be like, well, we don't have enough information, okay? So sometimes you're given information, it's just not written on the diagram that you have to make sure you see. Right here, hidden information. What's the hidden information we have? This shared side. It's the same length in both. So I'm just going to put 3. So which method can we prove these two triangles congruent by? Side, side, side. What about this one? shared side. So they're congruent by side, angle, side. SAS. That would be SAS. Okay? I feel like we're getting it. We're getting there. We're getting there. All right, we're moving on. Oh, that's my hat picture from last year. Or no, from 2018. 2018. And these I don't know why I think Chihuahua pictures are so funny. Have I showed you guys the Chihuahua or muffin meme? It's hilarious. I'll have to show you. Chihuahuas, they just put a bunch of pictures of Chihuahuas and they mixed a bunch of pictures of blueberry muffins. It's hilarious because the Chihuahuas look like blueberry muffins. Okay, it's fine. It's fine. Review. Which pair of triangles is congruent by side, side, side? Yep, because we have this side right here. So that is 4. Which pair of triangles is congruent by side, angle, side? 1 is angle, side, angle. Hold on, let me show you this. Vertical angles, right? So that side is in between the 2 angles. So this would be angle, side, angle. This would also be angle, side, angle. This one, this one's SAS. Not every right triangle have to be congruent by hypotenuse leg. They don't have to be. It's just if you see right triangles, you can check to see if hypotenuse leg is a way to prove those 2 triangles congruent. What about this one? Last slide in my recording, that is. Which pair of triangles is congruent by angle, side, angle? Yes. Angle. Okay. Angle, side, and the angle, the vertical angles is the second angle. Nice. All right. Peace out.